So hopefully you're seeing my screen right now. I also put the link to this recap in the chat box. We'll update this based on the feedback and discussion off this workshop too. So stay tuned for that. So this is a little stakeholder workshop summary that is informing what we're calling a tale of two bays. It's a research collaboration funded by NOAA National Centers for Coastal Science. And so the first workshop was on September 17th, a few weeks ago, it seems like forever, where we had stakeholders in the region attend and learn about and help inform an ongoing research collaboration focused on modeling sea level rise, groundwater, and adaptation strategies in Santa Monica Bay. One of the first icebreakers we did was putting in the first three words that people thought of when they think of sea level rise. And so this was the word cloud that was generated from that meeting. You'll notice that Patrick Barnard is in there, which I thought was funny. But you know, the flooding comes out a lot, and adaptation, and that's really what we're here to talk about today, is flooding, adaptation, and kind of you know, steps moving forward both in modeling and implementation. And so I won't go through all of this, but in a summary, a tale of two bays, this project focuses on modeling surface and subsurface flooding with sea level rise and adaptation strategies in Santa Monica Bay and in Humboldt Bay. So we have an urban site and a rural site. The project is led by University of Arkansas and is funded through the NCOO's Ecological Effects of Sea Level Rise program. Our project partners include Point Blue Conservation Science, the University of Texas Arlington, USGS, Trinity Associates, and the University of California Sea Grant Us. And so I think most of our project partners are here in this meeting today. So if you have specific questions or want to reach out to them, I'm happy to provide those contacts. Again, there's a summary that was sent out in the agenda to the NOAA page that kind of goes through the project as well. And so this project is really building upon sea level rise modeling efforts like the Coastal Storm Modeling System, COSMOS, which I know most of you are familiar with through Adapt LA and through other webinars, and even in use in your local sea level rise vulnerability assessments and action planning. And we're taking this a step further to begin to understand the complex interactions of groundwater movement and the responses to a variety of adaptation strategies along the coastline. And so we are talking about the Santa Monica Bay area. It's an area of coastline that spans over 70 miles. We have many jurisdictions. We have many different types of coastlines, and we have a lot of coastal stakeholder interests. We have state parks, we have beaches and harbors, we have local city jurisdictions, we have nonprofits. We have a lot of stakeholders in the region. And so one thing we talked about last meeting was some of the science of COSMOS, if you're not familiar with. And so there's a couple links here. One is to Our Coast, Our Future, which is a map viewer to view different sea level rise scenarios associated with COSMOS. And then we also have a link to Sea Grant's Adapt LA website if you're interested in some other resources. And so in the first workshop, we introduced the Tale of Two Bays project. We had a couple of presentations, one from Patrick Barnard on the development of the Coastal Storm Modeling System, and then another one from Kevin and Michelle introducing the science of the project that we're talking about and dealing with today. And so if you if you missed the last workshop or want to recap at any point, we have a recording available on this map, story map and link. And so let's just recap really quick, because I think it's really important to start off the discussion from where we left off and to remind everyone kind of what we talked about. That way, you know, you can use this in your discussion. But during the breakout rooms in the last meeting, one of the tasks was to identify coastal values that were important to your organization in terms of, you know, managing the coastline, or how you see sea level rise affecting the coastline in the future. And so during the breakout room discussion, these were some of the coastal values that really popped up and were mentioned throughout all breakout rooms. And they included things like access to the coast for residents and visitors. We talked about cultural, recreation, and economic benefits. There was a lot of talk about protecting critical infrastructure, including residences, businesses, transportation, and piers. Highway 1 was mentioned a lot. there was a lot of talk about ensuring there is a thriving coast for future generations. We talked a lot about environmental values, including habitat and natural resource protection and restoration, particularly living shoreline applications and restoration of some of the Barbilt estuary lagoons in the northern coast, and the restoration of Ballona wetlands. There was talk about mental and physical health benefits of the coastline and how we can better serve underrepresented and underserved communities. Additionally, there was also talk about archaeological sites or cultural importance sites like the Adamson Beach House. And so I want you to think about those when we go into the breakout rooms, if there's anything missing, or if you want to elaborate on some of these values or sites, this is the time to do it. And then we talked about priority areas, and these were areas that could potentially be included in some of the modeling efforts that Kevin and Michelle will talk about here after me. And so one of the goals of this workshop is to try and narrow down some of these priority areas to figure out what we want to and what we can and what we want to be able to include in the modeling effort, noting that we can't model everything, and that this modeling effort is really hoping to develop a set of models for areas in Santa Monica Bay that are representative of different areas of the coastline to be used as, you know, tools in planning, but also as case studies for future model development. And so some general recommendations included focusing modeling efforts on important natural resources like coastal estuaries and lagoons, all the way to protecting homes and beaches identified as vulnerable through Cosmos. Additionally, we had some discussion about the feasibility of adaptation options for specific locations, like is there enough beach to implement a living shoreline project, or is this a feasible area for a seawall given the high interest and recreational value of the current beach? And so those are the kinds of discussions that circulated throughout the breakout rooms. And in the breakout rooms, we had 3 different breakout rooms. One was focused kind of in the Malibu area north of Santa Monica. And then we had another breakout room that was Santa Monica. And then we had another breakout room that was kind of South Bay focused. And so this is really transcribed from stakeholder notes with really no filter. And these were the areas identified in Malibu that could be used for discussion towards the after Kevin's presentation when we go into breakout rooms again. And so there was things like there's lots of shoreline adjacent development, homes, roadways, and utilities to consider. These little dots here were areas that were discussed in the meeting, things like Surfrider Beach and Malibu Lagoon, coastal estuary, restored habitat, but also vulnerable and having an eroding beach next to the historic Adamson House. Lots of stakeholders, things like septic systems were mentioned in Malibu. And so these are the sites that we want you to kind of dive more into and consider in our breakout sessions in terms of priority areas to include in this modeling effort. Scrolling down, we had another breakout session that focused on Santa Monica to Marina del Rey area. A lot of talk was around the Santa Monica Beach Restoration Pilot Project and other nature-based adaptation projects in the planning, if these could somehow be used as adaptation models for some of the groundwater sea level rise modeling. We talked a lot about the Venice and North Marina del Rey area as being highly vulnerable to sea level rise flooding as identified through Cosmos. And we talked about considering coastal communities that have also developed sea level rise vulnerability assessments and begun or finished adaptation planning, although we're never finished. And then moving down to the South Bay, we have some notes here of areas that were mentioned. We have Manhattan Beach, talking about the pier infrastructure and stormwater outflow. Also the beach bike path to the north near El Porto, and also the 28th Street Outfall Project and nature-based dune restoration project. And so these are some of the priority sites that were identified by stakeholders that we'd like to kind of dive deeper in. And so this will be updated after this workshop series to kind of add on to and show those refined thoughts and talk more about adaptation. But for now, I'm going to stop sharing my screen. I provided you the link with this if you want to browse around and if you think anything is missing or if there's other adaptation strategies that we need to put on the table, we'll have a chance to talk about that in the breakout rooms. So I'm going to stop sharing. I'm going to turn it over to Kevin and Michelle to go more into the science of the sea level rise groundwater modeling effort that we're here to talk to you about today.
All right. Thank you, Melody. We are really looking forward into diving into this more, giving you a little bit more of a sense of what sort of questions we can address with our coupled modeling. And so Michelle and I are again going to tag team on this presentation and try to give you some more details on our, not too much into the math of the modeling, but more what sort of things can we actually test? So what sort of adaptation strategies are going to be feasible to test in this scenario? What sort of scales are going to be appropriate for that as well? And so I wanted to start off by, again, making sure, am I showing my screen? Is this working before I go too far?
Yes, you're
Okay,
good.
good. There we go, and I can advance it, so that's a win. All right, so I've made a couple cartoons to show how groundwater can respond to sea level rise. And so this project is primarily focused on the coupled flooding effect of how surface water, storms, tides, waves, when those levels are elevated and they cause flooding, how can that create flooding further inland? And so how can that rise in the hydraulic pressure of that area change the water levels in the ground? And so this is something that we have a sense of in terms of very simple scenarios, and I'm going to show you some of these as cartoons, but trying to understand them at the landscape scale with adaptation strategies is something that we really don't know how it's going to respond. And there are questions of timescales, what timescales are appropriate, and so how fast, how large of a storm, how long of a storm is going to create a flood from the underground. And so flooding from below, is that something that's going to happen? Under what conditions? Over, is this going to be something that occurs more frequently in 2050, 2100 for certain areas and not? And trying to understand the processes behind those. And so here I have a cartoon that I drew that shows some of the things that people care about. And so the water table is connected. So the groundwater table is this dashed line for today, and it connects to the ocean water level. And this is, of course, going up and down with tides, waves, storms are going to elevate that as well. And so the work that we recently published as part of the Cosmos project was to look at what happens if we just raise that marine water level with sea level rise. And so the water table also rises with that, and we can look at places where the water table intersects the land surface. And this is what we call groundwater emergence. And that means mainly that groundwater is probably discharging from the subsurface, so it's flowing out of the ground, and that can create a surface flooding hazard, but it can also create a bunch of infrastructure hazards. And so that can happen at the coast. It mostly happens at the coast, but there are also areas inland where this water table is rising from the marine condition and it's intersecting the land surface up here. And so you get flooding where you don't necessarily expect it. And so the previous study was mainly trying to understand how topography controls this. And so I'm forcing you to change your perspective a little bit. I'll do it again on the next slide, unfortunately, looking north to south and south to north. But again, we have today's water table is this dashed line. We can raise it based on the same amount as sea level rise. And so if we have this delta SL as the rise in sea level, we can just raise the water table by sea level rise. But what that is actually a worst case scenario, because what actually happens is at some point the water table likely intersects the land surface, and where it intersects the land surface, it is going to flow out. And so based on the hydraulic parameters, the hydraulic conductivity of the ground, based on rock types, based on porosity, not really based on porosity, but related to porosity, it will flow out. And so you can create some flooding here, but you can also have more discharge in your streams. And so more flow in your streams, you have the potential to have coupled hazards. And so there's a lot of different things that happen, but mainly the point here is that when you have a depression in the topography, the water table will find the lowest point and it will flow out. And so generally we won't have the same amount of sea level rise, raising the water table is that same amount. So it'll generally be less. This is in a long-term sort of perspective. And so this is assuming that the water table has all the time in the world to respond to a rising sea level. That happens, right? Rising sea levels in terms of long-term climate change, that does happen over long periods of time. And so this is a changing baseline approach is what we did. But what we want to do with this study is really tie in some of the dynamics, some of the processes that are a lot faster. And so Michelle showed you this plot at the last workshop. And so all of these different features and different colors are all changing the position of the water table as these hydrodynamic processes are occurring in the surface water. And so where we would actually draw the real water table is a combination of all these physical processes in the hydrodynamics, and this is changing through time. And so as a groundwater hydrologist, I have a very hard time knowing where to draw what that water table elevation would be at any given time or place. And so that's where the numerical modeling comes in, where we can start testing the role of each one of these individually. We're not going to test all of them in this study, but we will have the combined effects and be able to turn some of them off to say, by looking at this piece and that part, we can say that the water table will respond in this way. And then we can look at the difference between these model outputs and learn something about this connection between the surface water hydrodynamics and the groundwater hydrodynamics. And so that's one of the main things that we don't really understand. We have a sense of the magnitudes of what's going on. We have a sense of how quickly water tables can respond in the subsurface to these changing conditions at the coast. But how they all combine in the real world is something that takes applying models in these real world places. And going beyond that, a big goal of this project and why we're having these workshops is we want it to be useful for planning these adaptation strategies. And so we have all of these coupled processes in the groundwater and the surface water, but then when we go and we build a seawall or we put in a dune, how does that change this connection? And so we want to understand the implications of what our adaptation strategies are. Are they going to enhance some sort of flooding that we didn't expect, or are they going to serve as a double protection against both surface water and groundwater? And so now we will jump into a little bit more about the numerical models. And so the scale is very important in what we can ask and how we can hopefully have model runs that are useful for your planning. Even if we don't have a model that's specifically for your area, we hope that the insights that we learned from looking at similar places where we have similar adaptation strategies, we can potentially apply those lessons in those other places. All right, Michelle, go ahead.
Thanks, Kevin, for that background. So as Kevin mentioned, then the scale of these models really governs what we can do and questions and options that we can explore. So one really important aspect of that then is the grid resolution that we're working with. So that again determines, how detailed can we be when we're implementing different adaptation strategies. So you can see the grid here for the Baywide domain for Santa Monica Bay, and the grid resolution across the entire domain is above 100 meters across the entire bay, but we do have these more nested domains within the large scale domain, and these are centered around particularly Marina del Rey and Redondo Beach. So if you go to the next slide, Kevin.
So before we step forward, I just want to say that for each one of these grids, each one of these rectangles, there is one value that the model is solving. Is that correct, Michelle?
Yes. So
there's one water level.
Right. Within this 100-meter grid cell, square grid cell, for example, you have one bed level, which represents either the bathymetry of the offshore area or the topography of the onshore area. And then we can model one water level within that entire range. And so if we want to get, as we move from this larger domain into the smaller domains, we can get more detailed in terms of determining what is the water level at point A versus point B. Whereas at the large scale, for the entire bay, we don't have that same sort of ability to resolve differences in water levels at high spatial resolution.
Perfect. Thank you for clarifying that. I wanted to just jump in, make sure.
Yeah, thank you. All right, so if we zoom in then to one of these high resolution domains, particularly Marina del Rey, you can see that we have several models here, or several domains, but the innermost grid is approximately 50-meter resolution. And so this allows us to resolve the main features of the nearshore region just off of the coast here, as well as the marina and Bayona Creek. And you can see on the figure on the right some of the details here. So this is showing the bathymetry within the region, so we can resolve fairly well the details of the marina and the creek. And then if you go, just advance one time, Kevin, if we zoom in then on the beach itself, you can see that we have about 3 to 4 grid cells across the width of the beach. And so that allows us to, again, if we're interested in implementing a seawall or a dune restoration project, we have some ability to change the model within those 3 or 4 grid cells to represent that particular structure, although we might not be able to get the very fine details of the shape of the dune, for example. All right, go ahead to the next slide. And then even within this Marina del Rey grid, we also have an even finer grid in the Venice area, which allows us to resolve the canals in particular, so we can then look at how the water levels change within the canal during the course of the simulations. Next slide. And then if we move down the coast to Redondo, in this area, the innermost grid has a resolution of approximately 30 meters. So again, we can capture the marina area, and we can also fairly well resolve the beach just north of Redondo, where if you kind of look closely, there's maybe 4 to 5 grid cells across the width of the beach in that particular area. But as we move further north and south along the coast, the beaches in those areas are not well resolved. So they're sort of in this 100-meter grid cell domain. And so in the current implementation of the model, that kind of limits what we're able to model in terms of adaptation strategies in those regions. But as we'll discuss in a little bit, there may be opportunities to further refine other parts of this grid in targeted areas, depending on the feedback that we get from the breakout sessions. All right, next slide. And then finally, Malibu came up obviously as a major area of concern during the last workshop. So again, with the current implementation of Cosmos, the Malibu coastline is not very well resolved. So this is actually in the outermost domain that covers the entire bay. So the grid resolution here is greater than 100 meters. And here you can see that a single grid cell really covers a large area, especially in the lagoon area. We can't really resolve the fine details of Malibu Creek or the lagoon or the shoreline within this region. So that again might limit our ability to implement adaptation strategies here, but there are opportunities to refine the grid in these particular regions if that is a focus area that we want to consider and really explore different adaptation strategies for. So hopefully this gives you a little bit of an overview of what the grid looks like that we're working with on the surface water side. And like I said, with your feedback from these breakout sessions, then we want to use that information to figure out where we need to enhance the model resolution. That way we can, again, explore these different adaptation options in more detail and really get a sense of how those impact the coastal water levels. So I'll pass it back over to Kevin, who will briefly discuss the grids for the groundwater domain.
Thank you, Michelle. So before I jump and show you a grid for the groundwater modeling, I want to reiterate that these are the surface water models and they're built off of the Cosmos grids. And so these have already been made, models have already been run, and Michelle already has some adaptation strategies that she's running through with these grids. And so this is a capacity that we already have. And our perspective right now is that we don't want to go around refining everywhere in terms of specific locations, because this is already a rich data set that this grid can produce. And so we can learn from what's already there. It's a lot of work to make these grids. And so we want to focus on what can we learn from the models that we basically have running, but there are opportunities for refining these. And so we do want to do that strategically. And ideally we'd be able to do it everywhere, but unfortunately that will not be possible. And so just to show you a little bit of how the groundwater model works. So each one of these yellow squares has one water level for every 10 minutes is what Michelle is sending me. And so I use that one water level, and then I set that value in the groundwater model to be the value that Michelle sent to me. And so for every 10 minutes, I can apply that to my groundwater model grid. And these are gigabyte size files. And so I've built a little model for around the Marina del Rey outlet around Bayona Creek. And so just to give you a sense, this is what a 10 meter by 10 meter grid looks like. And so I'm trying to run the highest resolution that we can, because of the research that we've done shows that topography is super important. And so Michelle was talking about bathymetry and showing you bathymetry. This is actually water table depth. So this is a model output here. But the bathymetry is, of course, the underwater topography. And so for both of us, the topography is super critical for understanding how the water level is going to cause flooding. And so just to give you a sense, when I do a 2-layer groundwater model, which is not a very, that doesn't have many layers, I'm looking at 580,000 individual points where I can get data. And so where I can predict it for every 10 minutes. And so I'm creating 13 gigabyte files by taking the outputs from hers. And this is for a relatively large area. To give you a sense of this, I ran 10-meter resolution models for the whole coast of California for only one time, so in steady state. And so this is feasible, but it's also dependent on the resolution of the water levels that I'm getting from Michelle's Cosmos models. And so they can apply how the water levels, how the waves, how the storms are affecting it here, and then the water table responses will propagate inland from those. And we'll get into a little bit of time series here, but I don't want to take too much time on that. And Melody, if you jump in right now, if that's okay.
Sure. And so, building off the models, one thing that we want to talk about in the breakout rooms is a variety of different potential adaptation strategies to implement as scenarios in these models. And so this is a green to gray adaptation figure, which most of you are familiar with. But when we're talking about green, we're talking about highly nature-based solutions, things like vegetation and natural habitats, building dunes, like that was discussed. That's a potential scenario to run in the model, different height dunes and changing that topography. There's also a potential for beach nourishment, although transport is not a factor in this modeling. So just what happens if you put more sand on the beach. And then we get into the opposite end of the spectrum, things like structure-based seawalls, but not just a seawall, like how high is the seawall? Is it a subsurface seawall? There's lots of different types of seawalls that can be incorporated into the modeling. And then somewhere in between, potentially, things like the Cardiff Living Shoreline Project that has engineered dunes. And so just to kind of get your minds thinking about the different types of adaptation strategies that you would like to see in different priority areas, we have this figure available. And so there's a potential to implement one type of strategy in one location, or maybe it's a few different types of strategies in another location. But what we're really looking for is areas and strategies that are representative of the coastline in Santa Monica Bay, or maybe different areas in Santa Monica Bay. Turn it back to you, Kevin.
Thank you. Make sure, here we go.
Okay, so so we have this range of adaptation options that Melody just talked about. This is another figure that's kind of showing how that might look along an open coast sort of situation here. And so we have the gray side with seawalls all the way to kind of a nature-based approach or a minimal approach, which might be something like beach nourishment. And so our goal here again is to model these, find a way to implement these within the models that we're using, and then test out how they affect both the surface water and groundwater flows. So in the next few slides, Kevin and I are going to talk about how a few of these strategies might be implemented within the models and what that might look like. So the first one here, let's say that we wanted to think about a beach nourishment project. In the bottom, you can see the bottom figure on the left side. I'm showing the actual profiles of an existing beach, as well as a potential nourished beach where we might raise the topography and change the beach profile in order to provide more of a buffer. So when we're actually translating that into the surface water model from Cosmos, we have to, again, think about what is the grid resolution that we're implementing. And our main, I guess, ability to implement this is by changing the topography. So we can change what is the topography level across the profile of the beach and how far does that extend offshore. But again, as we saw in some of those grid photos, we only have maybe 3 or 4 to 5 grid cells across the width of the existing beach. And so we have to sort of implement a stepped approach to the topography there. You can see kind of how it's not a smooth profile, but we do have that ability to adjust the elevation to simulate what that would do in terms of a flood buffer against future storm events. Okay, and then just before you move on, Kevin, I just also wanted to reiterate what Melody was saying, that these models do not simulate sediment transport or morphodynamics. And so within the model for each storm event, we're assuming that the beach profile would remain static, and we're not looking at how that storm event would impact sediment transport or erosion along that beach. We're just simply looking at what sort of impact it would have on the flood levels and flood extents.
Mm-hmm. Okay. Yeah, and these are sort of 1 to 2 day storms, and so they're not huge events, and we're not looking at the effect of multiple storms. So this is the same sort of thing, but from the groundwater perspective and a slightly different view of what how I would change the groundwater model. And this is, we'll fly through these, but with beach nourishment, right, we're changing the elevation, the tops of the cells. This could cause groundwater to be slightly deeper, and so maybe less likely to flood, but that means it's also there's more space there for it to actually rise with a storm.
All right, then another option might be dune restoration. So this is going to be very similar to the beach nourishment. Again, we're just changing the topography depending on what that dune would look like. But when you look at the numerical implementation, we obviously can't implement a super detailed profile for that dune. It would have to be more of this stepped approach where we could look at sort of the maximum elevation and general slope of the profile, but not necessarily the specific details of how that might be built.
And so here's just, again, similar sort of situation, more opportunity for the dynamics to occur.
And then finally, if we're thinking about a gray option, we might want to implement a seawall. And so in the seawall approach, we're not actually changing the topography of the model at all. We can just implement a hydraulic structure within the model at the boundary between 2 grid cells. And so that represents an impermeable, infinitely high wall that we can say would prevent water flowing into the cell behind the wall. We can also adjust the height of that wall if we want to look at different scenarios of potential seawall height as well.
All right, so this is where the surface water and groundwater modeling get a little bit divergent in how we can deal with it, because I have the whole subsurface that I can block. And so there's the option that I can apply her modeling results just at the surface and actually have no effect in the subsurface. And so this is what it would look like in terms of just adding a seawall at the surface. Basically, it's just blocking the surface water from affecting it, but I can create a deeper seawall that has a deeper impermeable foundation, and that's going to start changing how groundwater can actually flow towards the coast, and so that can create flooding on the inland side of it. And then also you could feasibly, not very economically, make a seawall that goes all the way down to the subsurface. And so this is what would happen, but then you're also blocking the ability of any of that water to discharge to the coast. And so that's going to flood behind that without having some sort of pumping implemented behind it. And then you need to know how much groundwater is going to flood behind. And so that gets more complicated. So I'm going to just kind of take this over, Michelle, so we have time for questions and everything really quickly. We do have model outputs with different sea level rises and storms. There is some effect here in Marina del Rey. We're actually seeing very little groundwater effect with just tides and storms because these are relatively short-lived, but we haven't really had the chance to get this fully operational yet. But we have a lot of opportunities to look at these coupled effects of surface water and groundwater. And so now we are going to try to transition. We'll have time for questions. I'll let Melody decide that, but we have some ideas for how we can start testing these different adaptation strategies and effects on that groundwater surface water flooding piece.
Thanks, Kevin and Michelle. That was awesome. So we have a couple questions that we can maybe get to before we go into the breakout rooms. Let's see. So we have one from Rosie, and I think this came up last time too, but maybe it wasn't answered. Rosie was wondering if we can import finer scale data on a project level, if available. There might be more details for several sites such as Malibu, Topanga, and Trancas, where recent bathymetry and top surveys were collected.
Yeah, so I think if we identify specific areas where we do want to resolve the model in more detail, then we're definitely able to implement that sort of finer scale bathymetry or topography data. And I mean, we would need that in order to resolve the model in more detail. So as we kind of discussed before, we are not necessarily able to do that in every location across the bay, but if we identify a place that's really of concern and that might be representative of other locations throughout the bay, then I think we would definitely want to move ahead with that and be able to explore those adaptation options there in more detail.
Great. And then we have a few questions from Jeremy Smith. One is, are you also using the XBeach results used in Cosmos to update the topography bathymetry on the beaches?
So we do have the capability to run XBeach simulations for wave run-up, but we are not updating the Cosmos topography and bathymetry based on any projected changes in the profiles.
And then one more question from Jeremy. Do you also have the ability to change the K hydraulic conductivity values for each cell?
Absolutely, yes. So I'm currently using a calibrated ModFlow model for the LA basin that the USGS put out. It is very low resolution, not very good resolution for the superficial materials. It's basically 50 feet thick with, I guess, so that's the actual model, but the hydraulic conductivity is more or less constant across. But with more data, if I can be pointed to more data, it's, yeah, definitely something that can be added at any point.
Thank you, Kevin. And so I think with that, does anyone have any more questions before we break out into discussion? There'll also be opportunity for questions afterwards or even following up. Okay. We're gonna go into breakout rooms again for similar to last meeting, but some of the prompts this time are different in terms of discussion. One question that we're looking to discuss is what areas and adaptation strategies should be used for the modeling effort, given the presentation that you just saw from Kevin and Michelle, and also the information gained from last workshop. And also, are there any other strategies to consider? So we talked about green to gray, we talked about various types of seawalls, nourishment, dunes. There might be potential, Kevin can clarify, for like pumping tide gates, because that came up in the last meeting as well. So if there's any other strategies that are missing here that are specific to locations that you'd like to see implemented, this is time to discuss those. And also, do these sites and adaptation strategies represent the region? Because it's important. We want to make sure that they represent the region so that they can potentially be scaled up in future projects, or we can learn from them. And so, yeah, I'm going to go ahead and put everyone in breakout rooms, and we're going to reconvene at about 10:45 and do a quick recap of what was the main points discussed in each breakout room and the next steps.
So how does it feel to have all the power to move people around, Mel?
I know, I was like, oh, we have 116 seconds till we're closed. I always wonder what great conversations I'm breaking up. Because it seems like they're always abruptly, you're like, and.
It seems like they should have like a countdown clock.
Yeah.
The countdown clock made me nervous. We were about to solve climate change.
Yeah, right. That's a good reason why we didn't solve it this time. Melody pulled us out of our room.
I know. Well, thank you, everyone. I don't know about the other breakout rooms. We had a really productive discussion. I think we're going to go around the table really quickly for the moderators. Phyllis can start off, or Kevin was in your room too, and maybe talk about some of the highlights that came out. Again, we're going to synthesize all this information and probably add it to that story map and release it to everyone so we can get more feedback. And there's definitely opportunities if you think of the solution to climate change when we're done with this meeting. You can also email. So if you have any other ideas.
So I'm going to actually ask Kevin what insights into like how you are going to sort of go forward with way more work than you have time to do. But what were the most salient things that came out to you in terms of where the next direction, where the direction should be for your modeling?
All right, so I'm going to have to look at the notes, but so one of the things that I think came across from a consensus is that we don't need to focus on the Malibu Lagoon in terms of there is need there to understand this coupled flooding potential, but it is complicated in a lot of other different ways, and there are other high profile needs that are kind of on the horizon. And so the two places that were highlighted are Topanga and Trancas. And so two places where there is current effects and current planning and so an opportunity to look at more of an open beach sort of perspective, but that is different than other parts of the bay. And so an opportunity to do a comparison there and look at these different effects together. Is that capturing it, Phyllis?
Mm-hmm. Yeah. I mean, we had a long conversation, some very valuable input from, people like Rosie and Christine about what planning efforts are kind of up in the air and how these could contribute to them. But that's a good recap of kind of like the bottom line for us.
Great. Thanks, everyone. And again, too, if you have any ideas or comments for other areas in Santa Monica Bay or the project in general, you can always reach out and ask those, and we'll get back to you or incorporate more feedback into this process. So for group 2, we focused on Venice and Bayona area because we thought it was worthy of its own discussion given the high vulnerability to sea level rise and kind of inland flooding through Marina del Rey. And we talked about a lot. We talked about a few different strategies that were on the list, things like seawalls and subsurface seawalls, but also potentially looking at underground like parking garages and basements that are used currently, but that could potentially be used in the future for like catchment pumping stations or areas. And so there was a lot of talk because of this area being so susceptible from the coast and inland about not just considering strategies individually, but considering the effects of strategies with sea level rise and groundwater together. And so combinations of seawalls and dunes, or seawalls and pumping stations, or dunes and seawalls inland, and how those two strategies would like interact with each other. Let's see. When we talked about how these sites represent the region, a lot of talk came about this could be representative and inform areas like portions of San Diego Bay, Los Alamitos, or areas of San Francisco that are particularly vulnerable to flooding. And then maybe I can call out Patrick to see if I've missed anything, or Jeremy, you can speak up too, because I know you had a lot of thoughts.
I think you covered it. It's great. Just a great site. So many different potential solutions, and then potential consequences of some of those solutions. And it's not just overland flooding issue here. It's definitely a groundwater issue as well. So we get it from all sides. And saltwater intrusion is another thing that was raised. It's something we need to address in this area. And the county is already doing that with injection wells, but that's another topic that we wanted to raise to Kevin, and just remind that that's as much as we can do on saltwater intrusion in this area, I think will go a long way as well.
Yeah. Thanks, Patrick. And then we have group 3, Michelle and Maya.
Yeah. So I think, so this covers a lot of the kind of wider sandy beaches, as well as some areas kind of further south in the South Bay that are already experiencing that coastal squeeze. So it seemed like a lot of the conversation here around Manhattan Beach, or most of the down to Redondo Beach, folks are already considering or implementing small dune restoration pilots. So it seems like that's a really a good location for those, as well as beach nourishment. The other thing that was a potential adaptation strategy that we hadn't talked about previously was sort of groins and breakwaters. So we talked about that a little bit, but that was a new one to consider. And yeah, just in this particular area, a lot of sort of beach access and recreational values that are important, not just locally, but also to the broader region.
Perfect. Does anyone have any questions so far? If not, we can start wrapping up.
So I did want to say that after we have officially wrapped up, I am available to stay on for a little bit longer if anyone wants to stick around and have a conversation.
Yeah, thanks, Kevin. All right, so I think with that, the next steps for this project is taking all this great feedback, organizing it and developing a list of sites, and also accompanying adaptation strategies to go along with that for Kevin and Michelle and the team to choose to move forward with good reasoning, from stakeholders, these being representative of the area, and ability to, have lessons learned and application to other sites in Santa Monica Bay and throughout California. And so we'll summarize these notes. We've recorded the session, so we'll provide the presentation section, not the breakout rooms, and the recap to everyone. And then we'll incorporate that, and we'll update the story map to kind of include the continuation of these thoughts and discussion on adaptation, and send that out to everyone. So if you have any questions in the meantime, feel free to reach out. Kevin's here to stay on if you have any questions about the modeling and project in general. And thank you for coming.